Hello everyone, we are from Truemaths, and in this video we are going to solve the first question of exercise 1.3. And in this question you have to write the following decimal forms, and you have to say what kind of decimal expression each has. Now first of all, let me explain you how many type of decimal expansions we have. So actually we have three type of decimal expansions. The first is terminating decimals. Means this decimals terminates after a certain point of time. Means 0.2 is a terminating decimal because after one digit it gets terminated, and 0.38 is again a terminating decimal. Again this terminates after 3 and 8. Similarly 0.456 is again a terminating decimal. It terminates after 3 digits. Now this is known as terminating decimals. Now what is the specific quality of these terminating decimals? That this is 2 upon 10 and this is 38 upon 100 and this is 456 upon 1000. So obviously if you want to terminate something, what you have to do is you have to divide that number by 10 or 100 or 1000, or you can say the power of 10. If something is divided by 10, 100, 1000 or lakh, or you can say the power of 10, that decimal terminates. Okay. Now how we can form a 10? We can form 10 by multiplying 5 with 2. So we can say that if in the denominator, if we have 5 or 2 or both, in that case that decimal will terminate. For example, this is 2 upon 10, this will terminate. 3 upon 4, again this will terminate, because in the denominator this is a power of 2. Again if I am saying this is 4 upon 25, again this will terminate because there is only the power of 5. And if I am saying this is 3 raised to power 20, again this will terminate because 20 can be written as 4 into 5. Again this is only the power of 2 and 5. So these decimals will terminate, and this is the, you can say, this is the condition by which we can find out which is terminating decimals. Now but if I am saying 1 upon 7, is it terminating decimal? So in this case, because in the denominator there is no power of 5 and no power of 2, so in this case this is not terminating. This will not terminate itself. So this is the second kind of decimal, that is known as non-terminating but repeating, or instead of repeating you can say recurring. So this is the second kind of decimal. If I solve this, I'll get my answer. So we have to divide 1 by 7, that will be point, that will be this 7, 3 and again 30, 4, 28 and so on. This will never terminate. Now there is a third kind of decimal expansion, that is non-terminating and non-repeating. So these are the third kind of decimal expression. These are basically root 2. When you will find the value of root 2, you will find the value of root 2 is neither terminating and it is neither repeating itself. So this is the third kind of decimal expression, and that is known as non-terminating and non-repeating decimal expansions. But if I talk about root 4, so this can be written as 2. So this is not a non-terminating and non-repeating. This is a perfect square. So except perfect squares, the other numbers are generally non-terminating and non-repeating. For example, root 11, root 13, all these are known as non-terminating and non-repeating decimals. So here you have to find what kind of decimal expansion this has. So obviously in the denominator there is 100, that is the power of 5 and 2 only. So obviously this will terminate itself, and obviously this is 36 upon 100, so 0.36 will be its decimal expansion. Now this is 1 upon 11. There is no power of 2, there is no 2 and no 5 in the denominator. So in this case, this will be in this second category, that is non-terminating but repeating. So this will be non-terminating but repeating, and the decimal expansion will be, you have to divide 1 by 11, and that will be 100, 9 times 99, 100, that will be, and again that will be 99 and 99 and so on. So the expansion of this will be equals to 0.09999 and so on. So this is the second kind of expansion where this is non-terminating, because it will not divide this number completely, but this will repeat itself. So it will be 0.0909, 0.0999999 will be the decimal expansion for this question. Now this can be written as 8 4s are 32 plus 1 is 33 upon 8. Obviously in the denominator this is the 2 raised to power 3. 8 can be written as 2 raised to power 3, and we know that whenever in the denominator if there is a power of 2 or power of 5 or both, so then in that case that expansion will terminate. So this will terminate for sure, and the expansion will be, you have to divide 8 by 33, so 8 4s are 32, 1, 8 1s are, so 4.125 will be the decimal expansion for this. Similarly, if you see this, there is no 2 and no 5 in the denominator, so obviously this will be non-terminating but repeating, and if you want to find its decimal expansion, in that case you have to divide 3 by 13, so it will be 30, so it will be 2 times 26, that will be 4, and it will be 3 and so on. So when you solve it, you will find this will be non-terminating but repeating. After a certain point of time it will repeat itself, same as this. Here also if you want to solve this, this can be written as 2 multiplied by 1 upon 11, and we know that 1 upon 11 is again a non-terminating but repeating, and the value of this is 0.0999 and so on, and this value is multiplied by 2. So the result will be equals to this multiplied by 2, this will be so this will be the answer here. Similarly, this, when you talk about this, in the denominator, this can be written as 4 multiplied by 100. So So obviously in the denominator there is 0 and there is 2 raised to power 2. So obviously this will terminate itself, and if you solve this, this will be 3.29 upon 4. 2, I can put a decimal here, so I have placed it here. Now if I solve this, this will be 0.8 2 so this will be the answer for this particular question. Obviously there is 5 and 2 in the denominator, so by this we can find, or we can specify that this will be terminating decimals and this will be its decimal expansion. So this is how we can solve this first question. I hope you have understood how to solve. If you like this video, please subscribe to our channel, and if you have any problem in maths, you can directly contact to us. The phone number, the email address and the WhatsApp number is given below in the description. Thank you.